Okay, so greetings. So welcome to today's class. So a quick recap. In yesterday's class, we looked at we started looking at suspensions, right? So we identified that broadly an automotive suspension has two components, like an energy absorbing component realized in the form of a spring, and an energy dissipating component realized in the form of shock absorbers, and other linkages which we will discuss as we go along. Okay. So yesterday we looked at springs, we looked at different classes of leaf springs and discussed their characteristics. We looked at leaf springs, torsion bar, coil springs and air spring. Okay. So today let us get started with discussion on shock absorbers. So what is the role of a shock absorber in automotive suspension? Okay. The shock absorber essentially is used to convert the kinetic energy to thermal energy, which is then dissipated. Okay, so that is the primary role of a shock absorber, and this way it will serve to dampen the vibrations, okay, like that come about when the wheel vibrates due to road perturbations. Okay. So primarily like what are called as oil filled telescopic shock absorbers are used in automotive applications. Okay. So what are these oil filled telescopic shock absorbers? Let us look at a simple schematic. So here we can see that like there are two tubes. Okay, we can see that there is an upper tube, okay, and a lower tube, and we can see that the two tubes can slide into each other, right, slide in and out of each other, right. So that is why it is called as a telescopic arrangement. Okay. And we can observe that the upper tube has an upper mount which is connected to the vehicle body. Okay. And to this upper mount is a rod, a piston rod, at the end of which there is a piston. Okay. And that is immersed in a hydraulic oil, okay, inside this tube arrangement. Now what is going to happen is that this lower mount obviously is connected to suspension linkages, ultimately connected to the wheel assembly. Okay. So as the wheel assembly vibrates or gets displaced with respect to the vehicle body, these tubes are going to slide relative to each other, in and out of each other, right. What will happen to the fluid then? This piston has small grooves in it, through which the hydraulic oil is forced from either the top side to the bottom or vice versa, depending on the travel of the two tubes. When the oil is forced through the small orifices, due to the viscosity of the oil, there is going to be energy dissipation. Okay. So that is how the shock absorber dissipates the energy and converts the kinetic energy to thermal energy and dissipates it. Okay. That is the mechanism of dampening the vibrations that are felt. Okay. So this is the typical arrangement. So let me write down the key points about the shock absorbers. So the shock absorbers are connected between the vehicle frame or body, okay, and the wheel assembly. So then the upper mount is connected to a rod which has a piston immersed in oil. So, this lower tube is called as a pressure tube. Okay. So, this lower tube in which the piston moves, inside a so called pressure tube, during which oil flows through small orifices in the piston, leading to energy dissipation. Okay, so that is what happens in the shock absorber. Now, broadly, like there are two strokes of this shock absorber. Okay, what is called as a compression or a bump cycle, and an extension or an rebound cycle. Okay, so we will look at both of them as to what happens. Okay, so two cycles or strokes, right. So, the first one is what is called as a compression or a bump cycle. So, in this compression or bump cycle, what happens is that the piston moves downwards, right, with respect to the pressure tube, and consequently the fluid below the piston is going to be pressurized, and that flows through the orifices. Okay. And in the extension or rebound cycle, the fluid moves the piston moves upwards relative to the pressure tube. So, the fluid above the piston is going to be pressurized, and the fluid flows downwards, okay, with respect to the piston. Okay. So, for example, when are we going to have a compression or a bump cycle? Suppose let us say we are driving a car and we go over a speed breaker, right. So, then we are going to have a compression or a bump cycle, right. So, let us say we go into a pothole, one of the wheels goes into a pothole, we are going to have an extension or a rebound cycle. Of course, when you have vibrations, we are going to have both, right, periodically. So, now depending on the number of tubes in the lower half, okay, we have what is called as a twin tube shock absorber and a monotube shock absorber. So, what are these? So, anyway, a shock absorber which is used in automotive applications has two tubes, an upper tube and a lower tube, right. What is called lower tube is called as pressure tube, which slide into each other. Okay. So, then what is a twin tube? Inside the lower tube there are two annular cylinders or tubes. Okay. That is why it is called as a twin tube shock absorber. So, let us look at them. So, let us look at a twin tube shock absorber. So, what happens in this twin tube shock absorber? We can immediately observe that now there are two tubes. So, this central one is what is called as a pressure tube, okay. And then you can see a small annular region between the central tube and the external surface of this shock absorber, which is what is called as a reserve tube or reserve cylinder. Okay. So, there is a pressure tube which is the central tube or central cylinder, and there is an annular region around it which is called as the reserve tube, and there is a opening which is what is called as a base valve, okay, which connects the pressure tube to the reserve tube. Okay. So, now what happens? So, this stroke corresponds to a compression cycle. So, when the piston moves downwards relative to the pressure tube, right, and the pressure tube is going into the upper tube, what is going to happen is that the pressure is going to increase below the piston, right. So, as a result we can see that the fluid flows from bottom to top in the cylinder, right, from through the piston orifices. Now when the piston moves in, so we can see immediately what is the role of the reserve tube, right. So the excess fluid when the piston moves on and pressurizes, because oil is incompressible, right. So almost incompressible. So what is going to happen is that, like, the excess fluid will go into the reserve tube, okay. So that is the purpose of a reserve tube. So the reserve tube acts like a reservoir, right, for the excess tube. Now during the rebound or extension cycle, the opposite sequence of operation happens, right. The piston is the outer tube is going to move downwards relative to the top tube, the lower tube is going to move downwards relative to the upper tube, and then what happens is that the pressure increases above the piston, and so the fluid flow is from the top to the bottom through the orifices once again, okay. So the reserve tube acts like a reservoir, right, to store the excess fluid, and even during the extension cycle fluid is anyway taken from it, right. So that is what happens in the twin tube shock absorber, okay. So a few quick points, we can immediately see that there are two tubes in the lower half, okay. So those are the pressure tube or cylinder and the reserve tube, okay. So the primary function of this reserve tube is that it acts as a reservoir for excess fluid, okay. So now there is a base wall through which the fluid flows between the pressure tube and the reserve tube. Okay. So these are the main components and operation of a twin tube shock absorber. So there is something called as a gas charged twin tube. So what happens is that in a so called gas charged twin tube shock absorber, there is some nitrogen gas, like which is filled at low pressure in the reserve tube, okay. The purpose of this having this nitrogen gas is to ensure that this oil is not leaking, like from the twin tube assembly with operation. Please note that, like with operation, like the tubes are going to be displaced relative to each other, and there is also heat energy, right, which essentially needs to be dissipated. So consequently, in order to prevent any leakage of this fluid, shock absorber fluid from the reserve tube, a small pocket of nitrogen gas is at low pressure is introduced in the reserve tube or reserve cylinder. That acts like a cushion, right, and also ensures that the fluid does not leak. So that is essentially what is called as a gas charged twin tube. So in a gas charged twin tube, a low pressure nitrogen gas pocket is present in the reserve tube, okay. That prevents the fluid from dripping or leaking out of the assembly, okay. So that is what is called as a gas charged twin tube, alright. So that is the twin tube shock absorber. Now the second variant is what is called as a monotube shock absorber. So, what is this monotube shock absorber? So, let us look at them, right. So, as the name indicates, a monotube shock absorber has only one tube in the bottom part, right. So, as opposed to a twin tube shock absorber. So, let us look at the monotube shock absorber. So, we can see that there is only one pressure tube as the lower tube, right. So, there is no what to say annular reserve tube, right, in the bottom part, okay. And there is a pocket of pressurized nitrogen gas which takes up the change in volumes, right, when the hydraulic fluid is pressurized, right, due to the compression and extension cycle, okay. So, this nitrogen gas is compressed or it expands depending on the stroke, and we have what is called as a floating piston, which essentially separates the shock absorber fluid from this nitrogen gas, okay. So, that is the main difference. So, as with the twin tube, we can see that there is an upper mount which has a rod which is connected to a piston which is immersed in this oil, right, and the oil flows through the orifices as the two tubes slide in and out of each other during the extension and compression strokes. So, the main difference is that, like, instead of two tubes in the bottom half, there is now only one tube, but at the bottom of the tube there is a high pressure nitrogen gas pocket, okay. So, that is the monotube shock absorber. So, the monotube shock absorber does not have a reserve tube, okay. It has a floating piston that floating piston separates the hydraulic fluid from the nitrogen gas. Okay. So, there are a few more components in the suspension system, right. We have looked at springs and shock absorbers. So, there are a few more components which we will encounter as we are going to discuss various suspension configurations, okay, other suspension linkages which play a critical role, right. Okay. So, before we look at different types of suspensions, like a few points to note and also a few terms which we will be encountering shortly. The first one is what is called as a sprung mass. What is a sprung mass? It is typically, if we visualize a suspension as a unit that has one lump of mass above it and one lump of mass below it, right, connecting two assemblies. The mass which is supported on top of the suspension, which includes the vehicle body, is what is called as the sprung mass, okay. So, the term sprung mass indicates the mass supported on the suspension system, okay. So, for example, the vehicle body, right. So, that is what is called sprung mass. The term unsprung mass is what is between the suspension and the road, right. So, it is the mass, it is indicative of the mass between the suspension and the road. So, what can the unsprung mass include? For example, the wheel assembly, the axles, right, the brakes, etc. Okay. So, the foundation brakes, right. So, the disc brakes and the drum brakes that are mounted in the wheel assembly, all those form part of the unsprung mass, okay. So, we use the term loosely sprung vehicles to refer to those vehicles that have a softer spring, okay, which implies better ride comfort or improved ride comfort, right. So, if you have a softer spring, that is going to absorb like variations or perturbations from the road, but that is going to be at the expense of, but there is a trade off in road holding, okay, and also other what to say, functions or requirements like cornering, braking, acceleration characteristics, right, of the suspension. So, that is the trade off that we have in a loosely sprung vehicle. The complement of this is what is called as a tightly sprung vehicle. So, these are all terms that we would be encountering when we deal with suspensions. So, a tightly sprung vehicle have a stiffer spring, right, as the name indicates. So, obviously they will have better road holding, okay, and cornering characteristics. The roll stiffness would be more. So, on the other hand, there is a trade off in ride comfort, okay. So, we can immediately see the challenge in suspension design, right. So, we want to have a balance, right, between the various conflicting requirements, like of an automotive suspension, right, okay. So, these are some terms. So, now the next topic that we are going to look at is how do we classify suspension systems. Okay. So, let us look at different categories of suspension systems. The first classification is going to be from the perspective of, I would say, broadly performance, right, and how adaptable it is and so on, right. So, from the perspective of performance, like we can classify a suspension into the following groups. By and large, like most suspensions which are used in road vehicles are what are called as passive suspensions. So, what is a passive suspension? Passive suspension means we design the suspension, let us say we fix the spring, the shock absorber, we select them, we install them in the vehicle and that is it, right. We cannot change the characteristics of the spring and the shock absorber as the vehicle operates, okay. So, there is always a trade off between various functional requirements of a suspension, and even as the suspension keeps on working, there may be some small variations in the characteristics of the spring and the shock absorber, right. So, those are limitations, but it is very simple and inexpensive, right. So, has a spring and a shock absorber with fixed stiffness and damping characteristics, okay. So, that is the main feature. So, obviously it represents a trade off or compromise between ride comfort, road holding and other functions, right, of a suspension, right. So, that is a passive suspension. Then we can have what are called as semi-active suspension. So, what is a semi-active suspension? So, as the vehicle keeps operating, okay, depending on the operating conditions and the response of the suspension to the vehicle's operating conditions, the semi-active suspension can regulate the damping characteristics of the shock absorber. The spring stiffness characteristics remain the same, right. However, the shock absorber or damper characteristics can be changed, alright, depending on the operating conditions. So, that is why it is called as a semi-active suspension. So, in a semi-active suspension, we typically use a variable damping element such as a twin tube viscous damper in which such as an adjustable, right, twin tube viscous damper in which the damping characteristics can be changed by varying, for example, the area of the orifice in the piston. Okay, so that is one way of this one. So, essentially let us see semi-active suspension, right. So, a fully active suspension, of course, in a semi-active suspension the stiffness characteristics, the spring remains the same, okay. So, that is fixed. So, there is improvement over a passive suspension. Of course, if you look at it from a functional standpoint, the best option would be what is called as a active suspension or a fully active suspension. What is an active suspension? And in an active suspension, in addition to a spring and a shock absorber, we have an actuator which can provide a time varying force on the sprung and the unsprung mass to regulate the suspension performance, okay, so that we can get very good control on how the vehicle is responding to road inputs, cornering, acceleration, braking and so on, okay. So, that is an active suspension. So, an active suspension uses an electronically controlled actuator to provide improved performance, okay. Of course, it is very good, but then like we have higher cost and complexity, and another important challenge is the actuator bandwidth, because we are going to have road inputs over a range of frequencies, right. So, the actuator should possess sufficiently high bandwidth to respond to a reasonably wide frequency range. So, those are challenges, like as far as active suspension is concerned.